right, so we just did double angle identities, now we do half angle identities. So sine of some angle divided by 2 is going to equal plus or minus the square root of 1 minus cosine of theta all over 2. Same thing with cosine, the only difference is it's plus on the inside. And then with this one, again, tangent is y over x, right, or sine over cosine. So notice how these, basically, if I put this over this, it'll become this, more or less. So, with that being said, anyways, doing an example, find cosine of 15. Well, what's the half angle? 15 is a half angle of what?
30.
Yeah, this is like cosine of 15 equals cosine of 30 over 2, right? So 30 is going to be my theta, but I'm doing cosine, so this is going to equal plus or minus the square root of 1 plus cosine of 30 all over 2. What is cosine of 30?
Square root of 3 over 2.
Square root of 3 over 2, right? All over 2. So, from here, I can basically make this 2 over 2. So I can combine this and this on top. So it's going to equal plus or minus the square root 2 plus square root of 3 all over 2. Alright, now we can pretty much leave that there. The only problem is this 2 on the bottom is still inside the square root. Agreed? So I'm going to multiply this over 2.
Yeah.
Oh, okay. So, never mind. Ignore what I just said. Since I have a fraction inside, I'm going to multiply it by the reciprocal. Right? So I get square root of 2 plus square root of 3 over 2 times 1 over 2. And when I do that, I get 4 on the bottom, right? So then the square root of 4 is what? It's 2, right? So that's going to be my final answer. It's plus or minus square root of 2 plus square root of 3 all over 2. Now, we did this yesterday. And when we did this yesterday, I got cosine of 15 to be what?
Be the final answer?
Yeah, just the final answer.
Square root of 6 plus square root of 2 all over 4.
So, these aren't the same, are they? Why would I get square root of 6 plus square root of 2 over 4 for one, and the other, when I use half angle identity, I end up with the square root of 2 plus square root of 3 all over 2. Well, the cool thing is, if you actually use your calculator, type this in and see what you get for a decimal number. Give it to me to like 4 places. Square root of 6 plus square root of 2, in parentheses, all divided by 4. Square root of 6 plus square root of 2, enter, and then divide by 4. And what do you get? .9659, okay? Now do the same thing for this one. Do square root of 2 plus square root of 3, enter, and then divide that by 2.
0.9659.
So even though they look a lot different, they're actually just the same thing. Using probably a bunch of math that even I would probably struggle with, I could probably get this to look like that. It'd just take a lot of, algebra, moving numbers around, multiplying by square roots, so on and so forth. Alright, so, any questions on this one? Alright, so next one, find sine of 67.5. Well, since we're doing half angle, sine of 67.5 is probably going to equal what? Sine of what divided by 2? 135. So, this is going to equal the square root 1 minus sine 135. Is that right? Number 2? You can speak up, it's fine.
Why is it cosine over there inside of the...
Because I wrote it down wrong to see if you were paying attention.
Okay.
Yeah, this should be 1 minus cosine of 135. Okay. So 1 minus cosine of 135 all over 2. So then plug and chug, square root 1 minus square root 2 over 2, right? Cosine of 135, square root 2 over 2. I'm testing you again. Should be negative, right? So 1 minus a negative square root 2 over 2. So this becomes positive. So again, I'm going to take this, multiply by the reciprocal. I'm going to kind of do a couple steps in one. 2 plus square root 2 over 2 times 1/2. So I end up with 2 plus square root 2 all inside my square root all over 2 on the outside. Again, you can do your plus minus out in front. Alright,
Where'd you get
not, what's that?
Where'd you get that, the other two, like where you divide all by 2?
Where did this
Like-
come from?
Yeah.
Because this is 2 times 2 on the inside, right?
Mm-hmm.
So I would get 4.
Oh,
Well, since it's on the inside, the square root of 4 is 2 on the outside. Now, which is it? Is it plus or is it minus? Because this is just kind of a general formula, so that's why they put their plus or minus. With this one, it should be positive, right? Because we're in the first quadrant. Okay, with this one, we're still in the first quadrant, so what should it be? It should be positive, so I shouldn't need my plus or minus. That's just a general affiliation with the actual identity. Alright, so that's half angle identity. The last thing that they're going to ask you to do is probably what? Anybody know?
verify.
What have we been doing about every day so far? Verify, okay, prove that something will equal something. Oh boy,
Is this going to take a lot of paper?
just that time. No, it shouldn't be that much. I was trying to pick one out that will be kind of tough, but not that tough. Which ones did we do? 26, 30, and 34. Okay. Alright, let's try this one. Secant of 2 theta equals So-
those out.
Can I cross what out?
The sign and negatives.
Can I cross these out?
Yeah.
Why not?
This is not.
Cause it's a negative.
This is like a group, this is like a group, okay? And where this is positive, this is negative, I can't just cancel them out, okay? Even though it sounds like a great idea, all right? But, does anybody see kind of something that we can get rid of right off the bat?
Oh, I tried.
Going back to, the first section, Pythagorean identities.
You take the square root.
Cosine squared plus sine squared equals what?
1.
1. All right, so secant of 2 theta equals 1 over cosine squared theta minus sine squared theta. Secant is what?
1 over cosine.
Is 1 over cosine, right? So secant of 2 theta is the same as 1 over cosine of 2 theta, right? What does cosine squared of theta minus sine squared of theta equal? Take a guess.
What?
What does cosine squared of theta minus sine squared of theta equal?
Cosine.
Negative.
Cosine 2 theta. Do I need to go any farther?
How did you know that?
It's on it's your double
That's what we
angle
just did today,
formulas.
right? Double angle formulas. Alright, so,
Oh my god.
that's kind of the theme for today is double angle. So that's what you're gonna be looking at and trying to decide which one to use. Okay? So, with that being said, your assignment's on the board. Obviously, if you have any questions on any of these other verifying ones, need to start, what do you change? We can always go over a couple more of those. All right?